quick video update with the system. I was trying to get a power reading on my receiver coils, which is almost 2 amps short circuit current from the receiver coils. You can see that goes to my receiver coils. Got them in tune. I have to be quiet. Everyone's sleeping in my house, but anyway, it's important to note that is dead short circuited. We still have phenomenal wireless power, like mind-bending amounts. The radiant energy is in the entire board. I was just cleaning the wiring up a bit and trying to max out the power on the resonant receiver coils. Here's the strange effect. The radiant energy is present in the supercapacitor and also in the multimeter very heavily. How bizarre is that? Like, I've never seen these type of effects occur before. No impedance when that bulb is lit on our output current. It's like the power is duplicating itself, or we created a type of bubble or field of free energy around this device. Here's our input. This is the board that runs it. Starter supercap, DC boost converter, 0 to 120 volt DC, feeds the transmitter. Transmitter sends out wireless power to 2 receivers. The receivers are in parallel. Their combined output goes through a solar charge controller, and it keeps that supercapacitor bank charged, which then runs an inverter. And it's important to note, when I touch the inverter, the bulb dims. Very weird. Very strange. The inverter is powered off, of course, which runs at 120 volt loads. So, basically what I do once the system is on, I have the solar charge controller recharge the capacitor bank that acts as a tank that runs to 120 volt loads, and I have it recharge the input battery. The key to this is having the correct isolation components. Now keep in mind, that's dead short circuited from the receiver coils, our power, at 1.75 amps. And if I move this around, I can get it higher, but our wattage draw will increase. Right here, we're almost at 2 amps now. The interesting thing to note is it seems to output the most power when it's a little below 2 amps. I'm not sure why. And we did increase to 16 watts on the transmitter's power consumption. So, I'm going to move this back to where it was. It's almost like a sweet spot with it. Ooh, and certain components will burn you and shock you when you touch them. Like the whole board will, you touch any metal part of the board or any circuit, you'll get zapped. I wanted to show this interesting effect with a neon right here. Like, just look. You thought the radiant energy was extreme with this thing? Like, the radiant energy is in parts of the board it shouldn't even be in, like in isolated DC parts of the system. It's on the top of the capacitor? How does that make sense? It's on the supercap. It's in the inverter, which is off. It's on the metal. It's on the metal, which are just my handles for the board. Those are just metal handles. It's over here. The radiant energy is like spreading itself. It's on my metal plate down here, my metal heat sink. And here's where it gets wild. Look at this. How crazy is that? That's some raw radiant energy. Raw radiant energy put to work. It's just a neon. It's on the super cap. It's on the capacitor on the DC isolation board. It's in our solar charge controller. Doesn't seem to impede its ability to function at all. Very weird. It's in this capacitor bank. At least it used to be. Maybe not anymore. Interesting. But yeah, I wanted to show that. So here's the dead short circuit current of our receivers. As you see, the wire just goes to the receivers. 2 receiver outputs in parallel. We'll do a voltage check. So that's our current. And just in case you don't believe that there's current there, we'll hook up this light bulb to it. So this is the current that's keeping the system self-sustaining. This is a halogen light bulb, 5 watt. And we're going to light it up to the point where it'll be at about 10 watts over intensity. So that's the power that's running, that's being pumped into the charge controller that keeps the system self-sustaining. Of course, with that load being lit, we're not self-sustaining anymore because we're drawing from it, so that light bulb's about to burst. I feel heat coming off that. So we will check. As you see, our power consumption didn't really go up at all running that bulb. It actually drops sometimes. So that's starting to smoke a little. So having 2 tuned receivers really helped. Here's the spark that comes off it. And why wouldn't it fall? Come on. Very small spark. We'll go to voltage. Oops, we're over 20 volts. The receiver coils are outputting 37 volts at 1.7 amps. So not much of a change on the transmitter's power consumption input. This board tells me how much wattage the transmitter consumes. When everything's perfectly tuned, like the system is now, the resident receiver coils place maybe a 1 watt load on the transmitter, and that's it. So here we are, 37 volts at 1.75 amps, and I short-circuited that, and the transmitter's input dropped, which is that interesting effect that occurs. So keep in mind that's dead short-circuited. That's a short, and I still have the ability to do this. Like, oh my god, that hurts to look at. I got this thing so finely tuned, it's like, it's crazy. That's so bright it hurts to look at. I can't keep holding this. This is burning my hand. And it's doing that at 14 watts. 13. Alright, and that's still dead shorted, which doesn't make much sense, but, damn, I didn't even get that close. The effect is phenomenal. Guys, this system is becoming something wild. So, yeah, I'll put this down here. And as you see, the system is only connected to an earth ground for its excess power. I will disconnect the meter and reconnect the solar charge controller now. I have to be careful. Touching any part of the board will give me a nasty shock. So our meter is disconnected. Reconnecting the solar charge controller. Now the system will begin to self-recharge. And then we can now have the ability to turn our inverter on and run loads. We are consuming 33 watts, 33.3. $33.4 watts. Just trying to block the blue light. And you can charge a phone here. What does it say? 40 watt light. I can run up to a 300 watt load here. And I took the fan out of that inverter because it was driving me nuts. And I almost noticed this load seems to be flickering. Interesting. So, Radiant Energy is getting to work. The only issue I'm having with this charge controller is the supercaps like being charged up to 13.5 volts, but the supercap doesn't charge them past 13 volts. I guess it's fine, but there's like a 10% window there we could have. There's like 10% more we could have that we aren't quite getting. And I'm all for trying to max out efficiency on this thing. So, it's pretty much about all I wanted to show. Yeah, I mean you can charge phones here, you can run loads. The system will self-sustain itself. It's only going to get better from here. And again, thank you to everyone who supports this. It is getting absolutely wild. It is getting crazy. Whoops. Like that, I can't even touch the metal or I'll get zapped. That is nuts. And keep in mind, this device puts out minimal sparks, because it is not your incorrectly built academic twisted Tesla coil. This is a real Tesla coil optimized for wireless power. As you see, it doesn't even emit sparks. So oh my god, that hurts to look at. So this is something else. It's a real Tesla coil acting as a generator, a self-sustaining generator. And yeah, there it is. Crazy that I'm gonna have to start wearing sunglasses in here. And all the extra power gets pumped out of the earth. We grounded the L2 of that receiver coil through a series capacitor into the negative of the transmitter circuit because we needed a reference point, and the other receiver coil gets earth grounded to that spot, which two different ground potentials, huge boost in power for the receivers. As you see, that's my messy toolkit. There's nothing under the desk. So, I've had friends and family check this out. It's getting crazy. I haven't placed this thing. I haven't had to recharge this thing in about 7 days now. I'm gonna see how long it can go. If it'll infinitely self-sustain itself until a component fails. Pretty crazy, huh? I'll move the meter, I'll shut it off. Give you a clean look of everything. And again, I'll stand up, give you a clean look of everything. It's just the ground wire where the extra power comes from. And I just disconnected it. I gotta reconnect it. I've been messing with it a lot doing videos. And I think that's connected. I can't tell. It's connected. As you see, it's connected to the green ground screw on the outlet. And that's a dead outlet. There's no AC there. It's dead. We're just using the ground connection. So here it is. The radiant energy is coming out of the earth. As you can see. So yeah, that's that. Try and move this a little bit. They're very light super caps. As you see, they're super light. So super caps, battery, very heavy. Battery, super cap, battery, super cap of equal value. But I can just, this thing is so light. Battery. So cool, huh? And I'll leave the video at that. I'll switch on a heavy load. Oh, it hurts to look at. And yeah, we've got real usable power for a time. Probably about 2 or 3 hours with that load. I have to shut it off, then it would recharge itself. So, cool stuff, huh? Cool stuff. Feel free to like, comment, subscribe to the channel. This is real electrical research, making breakthroughs lately. And again, thank you to everyone who supports this research. This company is beginning to grow, and it couldn't have grown without your support and help, and I'm deeply thankful to you all. It's getting very exciting. We're creating portable, powerful generators, and what an exciting time to be in. So thank you, everybody, and stay tuned. I'm not sure how long you want this video to go on for. I know you guys don't like long videos, but I'll end it there.